Hey guys, how are you? Happy Monday. Okay, today is Monday, April 27th. This is Math 8, and we're going to do something a little different today. I'm going to talk through the Lesson 20 quiz, okay? I'm not going to give you any answers, but I'm going to read through it. I'm going to explain the questions, and then you're going to go back to Google Classroom and take this quiz, okay? If you'd like, you could open this video up on your phone and watch it, pause it, solve the problem in Google Classroom, and then come back. You could also open up two tabs and have this video going in one and the quiz going in another, okay? So I hope this is helpful. All right, let's go through it. You're gonna need a pencil. You're definitely going to, do you need a calculator? Yeah, I would have a calculator. I also have a ruler, and I have my little piece of parchment paper. Remember, if mom or dad has this in the drawer in the kitchen, you could also use wax paper. It's a little slipperier if you have tracing paper or some very thin copy paper, okay? All right, let's read through this. All right, question number 1. Which sequence of transformations map rectangle A to rectangle B? Okay, when they say this map, which transformations map rectangle A to rectangle B? It's like, how do I get this on top of that? What's the transformations? How do I track this to this? So what maps A to B? Okay. Choose all that apply. So Micah, if you're listening, there are more than 2 answers. He's not here to ask. Owen would ask that too. Okay. More than 2 answers. All right. Now the first thing I notice is I'm going from A to B. So I'm going from here to here. So what happens to make it smaller, right? Think about all of the transformations, right? If we go back, there's a translation. If you look in your notes, that's a slide. There is a rotation. That's a turn. There is a reflection. That's a flip. And there's I'm going to spell it wrong, dilation, okay? And there's 2 things that can happen, right? With a dilation, it could get bigger or it could get smaller, okay? All right, well, if I'm going from A to B, they are not the same size. So I know one of them that I have to have, okay? Could I slide to get from A to B? Could I rotate? Now the rotations are tricky. So if you wanted to, you could, let me get in the corner of my tracing paper here. I'm just doing a quick sketch, right? I could get my ruler. I do have a ruler. I could have gotten my ruler out. So when they talk about rotate, that's when they put it here, right? Because like A says, rotate 90 degrees about the origin. Remember, when you rotate, these are rotations, 90, 180, what is that, 3 times 9, 27, 270, back to 360, okay? So if you need to do that, as we read these, remember that's a rotation. A flip is when if I had a spatula, I could stick it under there and I could flip it. This is the y-axis, or I could flip it over the x-axis. Okay, all right, let's read what they're asking. Okay, so to get from A to B, could I rotate 90 degrees about the origin? So could I rotate this 90 degrees about the origin and then translate it? Would that work? Translate, slide. Okay, read the next one. Could I dilate this centered at the origin? So that means the 0, 0 doesn't change. Okay, so could I dilate this and then could I translate it? Could I slide it down to B? How about number C? Letter C. Could I reflect it across the x-axis? So flip it down here. Then could I dilate it? And then could I slide it to get it here? Okay, D says, could I reflect this across the y-axis? So now I'm going to flip it and go this way. So it would be here. So could I flip it across the y-axis and then translate it and rotate it to get to B? And E says, can I rotate this 180 degrees, right? It doesn't matter which way we go, right? 180 will get me over here. And then follow it by a dilation and a translation. All very interesting. More than 2 answers. Number 2. Damien dilates triangle PQR shown on the coordinate grid with a scale factor of 1/2 centered at the origin. Okay, so remember we talked about that. That means that those points won't change. Then he translates the, oh, this is tricky here, guys. Watch. Now he's going to translate it. He's going to use the scale factor, right? So he's going to multiply everything, and then he's going to translate it 1 unit up and 3 units to the right to form a brand new triangle called P prime, Q prime, R prime. What are the coordinates of the vertices of the new triangle P prime, Q prime, R prime? All right, can I make a suggestion? Okay, I say the first thing we do, it is not going to be this answer, but the first thing we should do is probably figure out what are the coordinates of P, Q, and R. So right now, I'm not writing them. I want you to write the coordinates. So what are the coordinates of P? Right? What are the coordinates of Q? What are the coordinates of R? Write them here. Now we have a scale factor. So we're going to multiply those numbers by the scale factor. What was the scale factor? 0.5. So take your coordinates. Remember we did this earlier. Multiply them by 0.5. Okay, and now you're going to get a new set of coordinates. Now, if it were me, I would go back and graph those. So let's say that the new P is at, I don't even know, pretend. I'm going to pretend that it's like here, -5, 1. This is a scale factor of less than 1. So what's going to happen to this shape? It's either going to get bigger or smaller. What do you think? I'm not going to tell you. Okay, let's pretend that this new point is here, -5, 1. Now it says translate it up 1 unit up and 3 units to the right. 1 unit up, 3 units to the right. This would be the new P prime. So that's not where it belongs. But what I want you to do is go ahead and put this on here and then move it up 1 and to the right 3. That is the coordinate I want. Okay? So you have to do 2 things. You have to take care of the scale factor. Then you have to move this point 1 unit up and 3 units to the right. And once you've done that, then tell me the new coordinates, okay? All right. That's the trickiest one on the test, I think. Okay, next one. Yeah, you can see an E on that one. We're not there yet, but okay. Elena transformed figure 1 to figure 2. So she went from here to here, as shown. Which statement accurately describes Elena's transformations? Only one answer is correct. Okay, so this is only one answer. Okay, so it's kind of like the other one we just did, but now I'm looking for one answer. Okay, so let's talk about this. She goes from figure 1 to figure 2, right? So it's changing size. And note, look at the orientation. Think about, this is the right angle. Where's the right angle up here? This is the diagonal, right? The longest side. Okay. So size changes, and then they don't seem to be laying the same way. Okay. Which of these is true? Figure 1 and figure 2 are similar. What does that mean? I'll give you a hint. You need to go back to the very beginning of this lesson. In your book, we talked about it. Figure 2 is congruent to figure 1. We've also talked about congruent. If you don't remember, look up the definition. So are these congruent? Figure 1 maps or tracks onto figure 2. So I can go from here to here by a rotation, a reflection, and a translation. They're not the same size. D, figure 2 is congruent to a dilation. So this is equal to this with a scale factor of 3. Okay, now, instead of doing all the points, you could find a point. Like I could find this point and multiply it by 3 to see if it matches the point up here. The other thing that we can do is how long, I got a low battery, I better talk fast. How long is this side? What if I multiplied it by 3? Does it match up here? Okay, one answer. All right, and here's our E. I think you should try the E. It's not too terribly difficult. Okay, this is the E question. Describe two sequence of transformations that map figure A, B, C, D, the little guy, onto figure E, F, G, H. So how do I go from the little one to the big one? Little one to the big one. So first of all, they're not the same size. Now, you're going to tell me, they said 2. So you're going to use translate, rotate, reflect, and dilate. Well, they're not the same size, so there's a dilation. I can see it. Now, remember, when you talk about your dilation, this is what makes this an E. You're going to have to tell me what scale factor you used. And just a reminder, this is when you take the new coordinates or you take the new lengths and put them over the original. So let's go one more time. This is the original and this is the new. Will that help if I write that? Original and this is the new. So you might have to give me the scale factor. So you could say, oh, I dilated, A, B, C, D by a scale factor of da-da-da-da to get, H, G, F, E. And then what else did you do? Was there any reflecting? Was there any rotating? Any translating? Okay? All right. You can do this. You can do this. Okay. Good luck. I hope this helps. All right. I'll see you later.